Добрий день, шановні колеги. Дозвольте з вами привітатися. Всіх вітаю з Днем ГІС. Мене звуть Ляшенко Дмитро Олексійович, я професор кафедри геоінформатики Навчально-наукового інституту геології Київського університету імені Тараса Шевченка. Дуже радий всіх привітати, і запланована доповідь нашого директора, на жаль, не відбудеться. І я від імені колективу нашої кафедри, від імені інституту всіх колег виголошу коротку інформацію про нашу спеціальність, про нашу роботу. Отже, давайте почнемо. Dear colleagues, let me introduce myself. My name is Dmytro Liashenko. I'm professor at Geoinformatics department at Research Institute of Geology, department of at Tarasa Shevchenko National University of Kyiv. We work at our department with students in the sphere of educational program, geographic information systems and technologies. The origin of our profession began in ancient times, even during the construction of Egyptian pyramids, Roman roads, and aqueducts. The first geodetic calculation we used, which allowed to build these structures with high accuracy. Since then, geodesy has developed rapidly. New tools and methods have been created. More and more complex problems in the fields of architecture, construction, navigation, astronomy, and other sciences have been solved. Nowadays, the efficiency of work in geodesy and land management is ensured through the use of geographic information systems and technologies. We use GIS to collect, analyze geodata, and to help to justify various management decisions. Our specialists are starting to fulfill the goals for determining the legal boundaries of a land plot, help architects and builders in the implementation of infrastructure projects, assess the processes of urban expansion and changes in the natural environment, and explain what these changes. Create navigation maps for use with smartphones and topographic maps for military and tourists. The purpose of our education program, formatting of graduates, ability to solve problems of design, development, and testing, implementation and operation of GIS, application of software, primarily in the field of geographic information systems and technologies. We use data captured from UAV or drones, from LiDAR surveys. Also, we help our students to work with BIM models, digital analogs of buildings and structures, which together with GIS provide more efficient workflows, innovation approach to the design and construction of infrastructure for building smart cities. Also, we use global positioning systems. It is a huge technology for capturing spatial data in different applications. Geoanalysis and modeling is the heart of GIS. Specialists in the field of geographic information systems organize a variety of data to make management decisions in the field of territorial and municipal management, cadastres, marketing. Here you can see the field of expertise. We prepare bachelor degree graduates and master degree graduates. In the nearest future, we plan to open PhD program in GIS. In GIS. Our students are studying in the field of specialty, geology and land management. And here you can see admissions to the bachelor's degree program. Here you can see examples of working our students near Institute of Geology, outside this GNSS receiver. And here examples of required and selective components of our educational program. Training practices in geodesy our students make in different different organizations, such as Research Institute of Geodesy and Cartography, geodetic company Geomax Kyiv, Twiz company, System Solutions company, and etc. Our curriculum provides for a joint training of students by teachers from the Institute of Geology and the Faculty of Geography. Well, here you can see our classes at Geographical Faculty and Military Institution inside Kyiv National University, named by Tarasa Shevchenka. And here you can see the different possibilities to employment after graduating from our program. And here you can see our website, Instagram, etc. Thank you for your attention. Well, let's see our agenda. The next presentation is Yuri Velikodsky from National Aviation University. Yuri Ivanovich, please, are you here? Are you online?
Я з телефона вийшов, у мене дуже нестабільний інтернет. Чи можете ви показати моє відео?
Так, а ви надсилали зараз?
Я вам надіслав лист з посиланням. Бо це було б краще.
Так, ми зараз так і зробимо. Так.
А ось воно.
Да, бачу. Зараз швиденько його завантажимо.
Там треба тільки звук увімкнути. М, Це коли ви відкриваєте показ екрану, то там треба галочку поставити, увімкнути звук. А то зараз ми ваш звук не чуємо.
Так. І ще раз давайте галочку поставимо.
Ну, ви закрийте показ екрану, а потім, коли будете відкривати його заново, то там буде галочка увімкнути звук. І треба
Мгм.
зі звуком його показати. Отак.
Так, ось тут. Share
Там,
screen.
да, ви вибираєте екран, і там внизу десь галочка.
Share sound.
Да, щас саме.
І запускаємо відео, так?
Да, і тепер відео можна там на повний екран, чи там якось. I congratulate everyone on GIS Day. My topic is GIS education in National Aviation University. GIS education began 20 years ago. We have anniversary this year. In 2002, Professor Железняк founded the Department of Geographic Information System in National Aviation University. This department now is the Department of Aerospace Geodesy and Land Management. Here you can see our GIS team of lecturers, and I show some former professors of our department which now work in other famous universities. Professor Vitaly Zatsarkovny, Dmytro Liashenko, Viktor Kutrenko, and you can see our present staff on the GIS educational program. We work in Aviation University, and the accent of our research is mostly aerospace research. So we use aerospace data, space images, aerial images, unmanned aerial vehicles, and this data we use for in spatial studies. So our students has this accent of its topics as well. For example, we have a drone pilot school in our university, so our students can learn drone controlling and obtaining images from drone, and after this using these images in GIS programs. The second accent which we have is GIS programming. We give our students programming in Python, JavaScript, and they can solve more complex problems which is not available or allowed in standard GIS software. So I want to show you some diploma work, examples of diploma works of our students bachelor and master. The first work is devoted to demographic research. There was used data from censuses of population of Ukraine for different years. Now you can see a comparison of population in 1926 and 2001 for each district, rayon of Ukraine. So this comparison is not simple because boundaries of districts was changed, and we should use a special joining for identification of rayons. So, for example, we can see as the ethnic group population was changed. For example, decreasing by blue color of Ukrainian in central Ukraine, and increasing in West Ukraine. Here you can see changing of Russian occupiers in Ukraine. For example, in Crimea we have increasing for this period, and in some industrial regions. And at the same time, Crimean Tatars returned from deportation, and we have increasing in central Crimea. Several ethnic group was disappeared as a result of the Second World War. For example, Poles, Germans, Greeks keep some clusters of their habitation, for example, near Mariupol and Donetsk. So these maps can be used for demographic analysis. The second work is connected, similar for previous, but here it built a teen model of natural population growth for the year, and you can see that teen model give us another approach. It is not connected to some administrative units, and we have real territories which have similar demographic state, so it may be useful for demographic analysis. The next work is devoted to mapping of entrance. So this is our students of the first course, where they are from. There was used the data of database EDBU. The thousands of records in this database for each entrant contain information about a school, where it is studied, where he studies, and the program on Python used information from this record. He extract address of the school and make geocoding of this address to map the points of where from this entrance. So you can see maps for different specialities for regions of Ukraine and for settlements of Ukraine. We can use these maps for analysis of our admission company. The next work is about analysis of methods of building digital elevation model. In this work, digital elevation models were constructed using digitized contours of topographic maps and by different methods. There is a comparison of accuracy of these methods, we can see results. For example, we can see the most accurate method is TIM, and for example another method, ANUDEM, is in the best group, but it has hydrologically correct elevation model, so we can use this result for selection appropriate method. The next work is creating of orthomosaic, orthophotoplan of the park using the drone imagery. So the student was obtained images from drone survey, built dense point cloud, digital elevation model, and orthomosaic for the park using the program Agisoft Metashape. The next work is about a monitoring of consequences of present war. Now you can see image of Sentinel-2 for Irpin town in the March of this year. In infrared bands we can see fires by red color in one of days after shelling. This data was processed in Google Earth Engine. So the student developed a program which vectorize the area of fires, so you can see black polygons around these areas, this vector data, and after this the program calculate count of these areas, count of fires and area of fires. For example, you can see these results for different images, for different dates, for different settlements. We can see the maximum of fires in Irpin in March, in May for Liman, and for Mariupol the maximum was has a duration about 2 months. The last work is using of nighttime lights for analysis of state of occupied territories. Nighttime lights are presented in the such form. This is illuminated areas, zones for settlements. But this illuminated areas does not coincide with settlement polygons, as you can see. So it was constructed Voronoi diagram for settlements, and after this was the spatial join of polygons of nighttime light and polygons of Voronoi diagram of settlements was made. So in result we can obtain power of electric energy for each settlement for each year. And you can see, for example, time dependence for Donetsk and Luhansk, and we can see minimum in 2015 years. So we can analyze the economic state of some territories for which we have not any other data. I suppose, I hope that our students that studied in our department obtain necessary knowledge for working in GIS, and many of them work in GIS companies. So we can continue, and we should continue this work. Thank you very much for your attention.
Thank you very much, Yuri Alexandrovich. The next presentation, we have 1 minute, and the next presentation will be presented by Ivanna Zobniv. I should ask our participants. Я хочу спитати учасників, чи потрібно нам перекладати з англійської мови? Я міг би взяти на себе таку роботу. Чи всім все зрозуміло поки що? І я прошу задавати питання в чат. I ask everybody to ask your questions in chat, and this is a way to participants, to presenters answer the questions. Well, Ivana, are you here? No. Так, я не бачу Івани, мабуть. Well, okay. Maybe Ivana is absent at the moment. Let us go to the another participant, Olexandr Melnik. Are you here? Maybe Alexander will join us at 14:45. Zoriana Hostiuk, you can present your article. Зоряна, ви тут можете представити зараз вашу презентацію? Немає. Надя, а є там Зоряна, чомусь вона, мабуть, немає зв'язку з нею.
Так, доброго дня. Я щось не розумію, я її бачила тільки що. Зараз хіба мені треба спуститися поверхом вниз і запитатися, в чим проблема.
Так позвоніть їй. Позвоніть.
Тоді хвилиночку.
Так, тому що, мабуть, я міг би за Івану доповісти, але краще, щоб вона сама тут доповідала. Тобто, хто там у нас ще є? Ну, бачите, зв'язок, на жаль, не всі можуть бути присутні. Так, ну тоді можемо Роману Третьяку надати слово трошки раніше, або Юрію Андрійчуку, якщо вони присутні. Будь ласка. Мабуть, немає зв'язку з цими учасниками. Теж. Ну, давайте. Ви свою по цьому. Well, we have another option now. I ask Solomia Mokanu, our student, to present her work about Oleshky sand in Kherson region, because we are waiting for other participants because of their absence, because of electricity problems in our country nowadays. Well, you're welcome. I will припиняю цю презентацію. Слушаю. Юрій.
Так, Дмитро Олексійович, не знаю, в чим проблема, але Зоряна зараз на роботі вдома, бо має 2 конференції, і видно, що це тільки якісь проблеми з зв'язком. Дозвонитися теж до неї не можу, поза зоною досяжності. Поки так.
Good morning, everyone. I'm share screen. Okay. А надайте мені, будь ласка, право.
Так, що? Тут.
Okay. Please tell me if you please tell me if you hear my presentation. Okay.
We don't hear your presentation. No sound.
Що, не видно?
Не чути. You don't hear the presentation, yes?
Yes.
I'm sorry. Okay. Yeah. Yes. I'm so sorry. Okay, and if you hear now.
Dear attendants, the main provisions of the work of a second-year student of Tarasa Shevchenka National University of Kyiv, Mokanu Solomia, on the topic Geoinformational analysis of Oleshky sand's desertification threats. Climate change has accelerated dramatically in the last years due to use of fossil fuels and atmosphere contamination. The desertification is the degradation of dryland ecosystems in arid, subarid, and subhumid areas caused by changes in climate and human activities. In Europe, the Mediterranean areas are a hotspot of desertification because of soil erosion and land degradation. The process of desertification is related with the concoction of climatic conditions, soils, geomorphology, and anthropic pressure. Southern Ukrainian climate conditions are very similar with these in the Mediterranean. Oleshky sands in the Kherson region is an interesting object of research. It should be mentioned that Oleshky Sands territory is not a desert from a scientific point of view. The area has some features of a desert, but according to the temperature regime and precipitation, it should be defined as semi-desert. However, the climatic conditions here are very arid. The sands heat up to 75 degrees in the summer. Using the Google Earth Engine processing environment, a diagram was created showing long-term trends in temperature data from 2000 to 2022. We can see that the air temperature in this area sometimes reaches more than 14 degrees Celsius. The development of Oleshky sands is described by Kostachev in the 19th century. Oleshky sands have created by people because of cattle livestock overgrazing in the area. The ordinary vegetation was destroyed and sand was spread under the influence of wind erosion. Artificially planned dense pine forest restrains the desert. Large-scale fires often occur because the forest catches fire easily in summer due to weather conditions. Nowadays, a national park in the area was being created. One of the methods of desertification process research is remote sensing data analysis. Remote sensing allows to make real-time monitoring of such territories with image processing technique. Consider this method on the example of Oleshky sands. Earth observation with remote sensing technologies is a significant tool for monitoring and decision-making in the context of combating land degradation and desertification. It's covering a wide range of methods for measuring a significant number of environmental parameters and processes of Earth's surface. All sensors on satellite platforms are gathering the data that show the processes in the atmosphere, hydrosphere, on the Earth's surface. The conditions of soils, vegetation, water bodies, glaciers, snow cover can be visualized and assessed. Remote sensing data and interpretation in GIS environment allows to cover raw data into useful monitoring information for decision-making at the different management levels. The European Space Agency's Copernicus satellite program has opened up new opportunities of remote sensing data used for landscape degradation processes monitoring. The paper goal is making a visual and instrumental analysis of Landsat satellite images. QGIS and QGlobal tools were used to process image data. The comparison of the 1985-year image A and 2000-year B shows the forest area increasing, its result of counteracting desertification by forest planting. Let's compare the 2002 Landsat 7 image C and 2013 Landsat 89L2 image D. The degradation of the forest cover and the increase in the sand area are clearly visible. It proves the need for constant monitoring because the rare desertification may occur, which could extend to other parts of the territory. The important problems of forest conservation in the area are wildfires, which also contribute to desertification. The pine forest in Oleshky sands often burn. Sometimes ignitions have natural origin. A small piece of glass acts like a lens that focuses the rays of the sun and sets fire to the needles. But most fires, experts say, are caused by the human factor. When the air temperature approaches to plus 14 degrees Celsius, the soil temperature in the area reaches plus 70 degrees Celsius. The area is popular tourist destination. A fire might occur due to their carelessness. The important factor should be taken into account is that all these forests are artificially planted. The pine tree landscapes are not a natural ecosystem, so the forest area is constantly decreasing without people assistance. It's difficult to study the wildfire forest losses from the natural color image A. The image in sphere diapason B shows the consequence of the wildfires. During the August of 2022, there are numerous wildfires caused by Russian aggression into Ukraine. According to the State Forest Agency, the number of forest fires in Ukraine compared to the same period last year increased by 2.3 times, and the area of wildfires skyrocketed by 77 times. In 70% of cases, the forest fires this year were caused by active hostilities, shellings, cruise missiles, mine explosion, and etc. Also, wildfire spread facilitated by strong gust wind. In the picture C, can see fire and smoke, but sphere image D shows burn forest covered a large area. Conclusion. Forest wildfires and inappropriate land management and forest plantation carry around the sand arena predetermine a vast danger. Forest fires, which destroy large areas of pine forest, are a significant environmental problem of Kherson region, as they lead to the emergence of large forestless areas. The natural renewal doesn't occur on the areas because of unfavorable climatic conditions of the region. The geoinformation analysis is able to make forest stocktaking and sand spread easy. It's not easy to create ideal conditions for the forest growth. As mentioned earlier, the problem of forest wildfires and desertification should be solved with the help of remote sensing and geospatial analysis. The paper, Land Cover Dynamic Technique, has been proposed. It consists of different remote sensing data combination. The visual analysis has been made by Landsat. The planetscope images were proposed in GIS environment. The perspectives of research lays in highlighting the difference between healthy vegetation areas and burn areas in consideration of their different signatures. I'm so thank you for your attention. I'm so thank you for your attention.
Well, Olexandr Melnik, now it's your time to join us.
Дякую. Доброго дня, мене чутно?
Так, вас чути.
Дуже дякую. Значить, я почну. Ой, а можна мені включити демонстрацію екрану? Щось воно не дозволяє.
Зараз.
Ну, бачу, да, робить. Видно мою презентацію?
Так, видно.
Дуже дякую. Значить, ну, за домовленістю я скорочую суттєво буде не 15 хвилин, трошки коротше. Я в чат зараз скину посилання на сайт нашої асоціації і скину попередньо записана моя доповідь відносно наших проєктів, а інша доповідь – це за проханням вашого керівництва трошки про ситуацію з працевлаштуванням у Фінляндії. Тому що сьогодні обговорював питання, до речі,
Олександр,
Данії.
let
Так.
me translate. Дозвольте переклад.
Так, будь ласка.
Alexander told that he will give links to these presentations and tell something about GIS jobs in Finland, where he is just now.
Можна продовжувати. Дякую. Дуже скорочено про наші проекти. Дуже такий вдалий в нас з того року розпочалася ініціатива. Ви приймаєте в цьому участь, ведете окремо, скажімо так, свою діяльність. Звалась вона «Історія на карті», вона була спрямована на історію давню, спадщину. Але зараз в цьому році все перевернулося таким чином, що потрібно вже історію сучасну відслідковувати. Будь ласка, перекладаю.
Alexander told about history on a map, a great project that has been presented by GIS-association, and he told that they have been working on ancient history, but nowadays the more important is nowadays history and пожалуйста, Олександр, дальше.
Дякую. Ну, я доповню, я думаю, що з перекладом теж зроблю. Будь ласка, значить, ще у нас ініціатива достатньо давня, ми її проводили в тому числі в університеті Шевченка, так звану практичну школу. Все це ми зараз накопичили, ну, можна сказати, в лапках завдяки ковіду на Ютубі. Можна подивитися різноманітні наші практичні заняття в вигляді відеоуроків. Так що, будь ласка.
Alexander told about GIS practice school. All these results have been created during COVID epidemic. All these lessons are available on YouTube, and you can use it for your own purposes.
Так. Ну, я думаю, що зараз підключиться партнер, новий наш партнер з того року, компанія Beholder. Якраз ця діяльність стосується безпосередньо вашого інституту геології. Тобто це використання штучного інтелекту в геологорозвідці, скажімо так. Звуть лідера цього проєкту Андрій Сівриков. Я подивлюсь, може він, я дав йому посилання, може він підключиться. Дуже цікаво, матеріалів багато, я скорочу, якщо буде потрібно, окремо розповім про цей проєкт.
Another interesting project is using artificial intelligence for geological purposes. The company Beholder, which are working on at oil and gas exploration, maybe the leader of the company will join us soon on this event.
Так. Для тих, хто зараз роз'їхався по світу, потрібна все ж таки комунікації, присутність як і до війни на різноманітних заходах. Ну от в переліку Це наш ресурс, дайджест такий, кожного місяця ми робимо. Велика подія була зараз, це Інтергео, всі знають, була українська там місія. От, і ми зробили репортаж відносно цього. Ну, є свої там експертні заключення з приводу запропонованих технологій і таке інше. Ще одна
Alexandr told about Intergeo Summit. Nowadays, many professionals from Ukraine are in Europe, and they GIS-association have been prepared reportage from this event, and you also can join, can take the information about this event from the GIS-association web page and YouTube channel.
Дякую. Ще одна подія відбулась в місті Переяславі. Це традиційний вже захід, він зветься «Фактор простору в історичних дослідженнях». Проводить його місцева наукова установа «Заповідник Переяслав». Також ваш університет приймає в цьому участь постійно, ваші студенти. Дуже цікава подія.
Another event was River Dnipro Revучий. It's annual event in Pereyaslav-Khmelnytskyi district near Kyiv. This year it took place in very small scale because of war. I see Andrei Sevryukov join us, and he is online.
Yeah.
Everybody can ask him questions about his company, about his project, and share their contacts in the chat.
Дякую. Я продовжую і зараз закінчу, будь ласка, надасте слово Андрію. Значить, якраз він, мабуть, що і розповість от про веб-саміт, він був присутній на ньому, так що я не буду доповідати, ви запитаєтесь Андрія відносно цього саміту. Традиційний наш проєкт під назвою «Дніпро Ревучий», в якому приймав Дмитро Лященко в тому році, Ляшенко в тому році безпосередня участь. Цікава подія, цього року вона сталася за умов обмежень певних військових. Але ми продовжуємо цей проєкт. Є надія, що ми будемо знаходити кошти для цього проєкту і просувати його по різних напрямках.
Well, Alexandr told about Dnipro Revучий project. The one case study in the project is a modeling of settlements that has been underwater after the building of Kremenchuksky reservoir on the Dnipro River, and we promote GIS technologies and are looking for new students for our universities and spread knowledge about GIS.
Дякую. Я завершую. Я ще додав в чат посилання на наші ініціативи останнього часу. Запрошую до партнерства, запрошую до співпраці. Ну, я не зафіксував, тобто я безпосередньо зараз знаходжусь в місті Маріахамн, Аланський архіпелаг Фінляндії. Тобто це на Балтиці, відносно цього ми там робили вже спільно декілька записів. Якщо цікаво, можу розповідати про місцеві умови і так далі. Дякую за увагу, я відключаюсь. Дуже дякую.
Well, Alexander explains that now he stay at Finland on the Baltic Sea islands, and they have working out different initiatives in GIS in the area, and he asked everybody to join him and get more useful information about this. Well, if someone has questions to Alexander, you can type it down in the chat. And now I would like to give the word to George White. George, can you hear me? Are you here?
Yes, I am. I hear you. Can you
Thank
hear
you
me?
very much for joining us. George, please introduce yourself, and I will give you host abilities now.
Okay. Let me see. It still says.
Олександр, please, Олександр, віддайте ваші хост Джорджу.
Still disabled.
Натисніть на ім'я Джорджа і скажіть, щоб він був хостом. Получається, Саш?
I'm still disabled.
Олександр, ми вас не чуємо.
Я зробив організатором, правильно?
Да, все, окей.
Включайтесь, будь ласка.
Ага, okay. So can people see my PowerPoint screen?
Yes, okay, we can see and hear you.
Okay, thank you. Yes, my name is George White, and I'm at South Dakota State University in the United States, and I'm very happy to be here with you today to tell you about some of the things that we were doing in geography in America. I want to begin by giving you some context. As I said, I'm from South Dakota. Probably many of you have not heard of this state. I know California is more popular, New York, Florida, Texas, but South Dakota is one of the smaller ones. We're in the central north of the country. We only have a population of about 900,000, so we have fewer people than the number of people in Kyiv. However, we're almost 200,000 square kilometers, so we're about a third of the size of Ukraine. We have in our system, we call it the regental system, 6 universities, and I drew a circle in blue around South Dakota State University. It's the largest one. We have over 11,000 students, which I think is probably still very small compared to you, but we are a small state. In our 6 universities, there are maybe 35,000 students in all of them. Just let you know that sometimes when I talk to Europeans, they will say University of or State University. For us, these are different universities. So I'm top one here, South Dakota State University. Our colors are blue and yellow. Our other big university in South Dakota is the University of South Dakota. So 2 different universities. Their colors are red and white. So they're much different. They're our competitor. We like only blue and yellow, no red and white. Our university is what is called a land grant university. Every state has at least one. And what this means is that we have an agricultural orientation. So many of the faculties are oriented towards agriculture. We have a college of agriculture, food and environmental sciences. Engineering is also part of this agricultural concept because they work on tractors and other machineries that help support agriculture. And then geography, and my faculty is called Geography and Geospatial Sciences, are in the College of Natural Sciences. So we are together with biology, physics, and chemistry. What's significant about us is that we have a national research facility near us. It's less than 100 kilometers. It's called the Earth Resources Observation and Science. This acronym is EROS, and it's the largest collection of remotely sensed imagery in the world. So all the satellite imagery is collected, especially by American sources, is deposited, kept here in this facility. They also collect a lot of satellite imagery from other countries. And NASA, I think you're familiar with, places all of its satellite imagery here as well. So here's the building. It's about 600 people. It's out in the middle of a cornfield. Probably many of them are engineers, but about 200 of them are geographers. And this agency is important to us because it's helped make geography at South Dakota State University very important. Without them, we would be just 2 or 3 geographers teaching, basic geography to students. But because of them, and they wanted geographers to work on the satellite imagery, we have a master's and PhD program. And that's one of the trends in American science, or geography in particular, is that satellite imagery has become, so popular over the years. When I was a young student, it was a specialty of only a few people. Now we're using imagery in many areas of geography. Here is an image of the Landsat satellite, which collects satellite imagery on the Earth. And as you can see, it began in 1972, and they've launched several satellites since then. And our most recent satellite was only launched a couple of years ago. So it's starting to give us new, higher resolution data. So here's, we call it departments that are faculty, Geography and Geospatial Sciences. We were the Department of Geography until 3 or 4 years ago. We added the name Geospatial Sciences because in America, a lot of people do not know, what geography is. When they look at you, you say geography, they're not sure what that is. So we added the name Geospatial Sciences, and people say, oh, wow, science. Yeah, that's great. We understand that. Yeah, and we even have Ukrainian students come and study with us. So originally, part of the trends that we had was there was GIS, and we called it just simply GIS, Geographic Information Systems, going back at least to the 90s, even before the 90s, 80s, even 70s. Then there was a movement to add the C to make it a science, so not just a software, a mapping software, but a full system of science. When I was young in the 70s and 80s, remote sensing was a separate topic. The people who did remote sensing didn't interact very much with people who did GIS. They were different. And in fact, when I was a student in the 1980s, we called it aerial photography. So photographs were taken from airplanes from about 3,000 meters, 3,300 meters. And I remember that's how we learned, was from photographs. Satellite imagery was available. It wasn't used a lot at universities. It was very expensive. Only some researchers were using it. But one thing I've noticed over the last 20 years is that GIS and remote sensing are merging together. So instead of being separate pursuits, not quite separate disciplines, that they're working very closely together. Almost everyone now is using satellite imagery in their GIS. bringing it in as one of their GIS layers. And this is one of the reasons why we started using the term in the last 10 years of geospatial sciences. It's a combination of these areas of research. As I mentioned, we're an agricultural university, and merging that with the technologies, I've seen aerial photography go away. Hardly anyone uses it anymore. Now we have the introduction of UASs, the unmanned aircraft systems, generally what we call drones. We're using them heavily here at our university. In fact, we have a new professor in the department who uses drones, and it's in agriculture. So we went from photographs at 3,000 meters up to satellites, and now down to drones, which are in this case a few meters or maybe 200 or 300 meters. There's a link here if you're interested. Maybe Dmytro could provide it to everybody. It's a news story that's on our local news about our work with local agriculture. In fact, part of the funding for our professorship came from our agricultural college. What's really popular in America now is called precision agriculture. So the idea of using technology to help farmers become extremely efficient. And so we get funding to help farmers with this, the idea of using drones and imagery, and then putting them in the GIS to look at farming fields so that farmers could more precisely apply water, apply chemicals, fight like weeds and pests and other kinds of things to maximize agricultural production. We have another professor in the department that is part of what's called the Land Cover Project. So this is with ARROS, that science center, our National Science Center that I talked about. And one of their concerns is mapping the type of land cover that we have in the United States. And not only the United States, they do it in the world. So they're using different satellite imagery to put together what we call land cover maps. We have another professor in the department, and these are part of national trends. I mean, I'm talking about my department, but many other geography faculties are also engaging in similar work. So he does vegetation phenology. So in the satellite imagery, that's being analyzed and talking about what kind of land cover we have, he's concerned with seasonal changes in the land, so that when we're taking our imagery, that what we're sensing from March and April, and then moving up through the summer period, and then we come down in the fall as many crops, because much of the United States is covered, the land use is agriculture, and so when we are taking these images, it depends on what time of year it is. So a lot of his research, and a lot of research going on now using remote sensing and GIS, is looking at the production of biomass over the time of the year. And certainly that's becoming more important as our climate is changing. We're getting, in some places, warmer temperatures and sometimes more wetness or dryness, and this is affecting plant cycles. And so his remote sensing is all looking at phenology, changes in plant growth over the year. And he is working with NASA. I think you've heard of NASA. His name's right here as the principal investigator. So he gets a lot of his funding from our government to do this work. Other trends that are happening in the US, especially with GIS, is what we call emergency management, because we have a lot of, you can consider it, per se, natural disasters. In this case, it's California. Temperatures are rising in California. We have more and more forest fires every year. It's burning down people's houses. People are dying, and California is a very populous state. We have almost 40 million people living in California, and it's a crisis in many ways. We have a professor who does GIS, no remote sensing really, although he will put in some remote sensing images in his GIS layers. But one of the emergency management topics that GIS people are doing is what we call like evacuation. So in other words, there's a fire, we got images of fire, people are in danger, they need to leave, they need to live quickly. The thing is, we've got roads, a particular infrastructure there. Sometimes the road they have takes them into more danger, into the fire, and people are panicked, they're very stressed. And so the idea is we're building these models for communities so that if there's a fire, or in other parts of America, if there's a hurricane, because we have problems with hurricanes, or also California, we have many earthquakes, and we need to evacuate people, get them to safety. We're using a lot of GIS then to provide people with immediate knowledge so that they know the best pathways to safety. So he's doing a lot of work in building these GIS to help with this. And it's not just emergency management. We're also concerned with human health in the United States. I don't know if you noticed, but we eat a lot of sugar and fat, a lot of hamburgers. A lot of people are unhealthy in America, and we're talking about that we need to be healthier and exercise more, etc. And so, the medical community is concerned about this, but geographers contribute through GIS in trying to measure healthy areas in America and unhealthy areas, and even using GIS to help people do more exercise, go to the gym. So a lot of different topics we're doing. One of the last ones I want to mention here is we have a professor that works on ecoregions, particularly our region. So here's Brookings right here where we are, our university, and it's part of a broader region called the Prairie Pothole region, which was a glaciated area of North America. So we have all these kettle lakes, which is another name for, is more of the scientific name for pothole. And it's also important because we call it our duck factory in North America. It produces or is a habitat for a lot of wildlife in America. And so some of the GIS work he's been doing is measuring these lakes over time, because as our climate's changing, a lot of these lakes are drying up and we're losing habitat for wildlife. And so his work is to use GIS to understand the change in this environment. The last thing I want to talk about, or second to last thing maybe, is trends in geography over time as we deal with the public. I mean, we have this problem that people don't know what geography is. They think it's studying capitals of countries, etc. And the general population has become more interested in the environment and understanding climate change and living in the environment. So when I was a young student, a lot of geography departments added to their names by calling themselves geography and the environment. I mean, a lot in biology were studying the environment, and a lot of young people were going into biology because they were interested in the environment. And they had no idea that geographers were interested in the environment. So many of our departments around the US changed their names to Geography and the Environment, or Geography and Environmental Studies, or Geography and Environmental Science, to attract students and also tell our politicians that yes, geographers have something to say about the natural world. I've noticed in the last 10 years, departments are now changing their names more in the direction of sustainability, because sustainability is becoming an important topic. We feel in geography, we've always been interested in sustainability, but again, people don't seem to make the connection between geography and sustainability. So we put that in our names now. And at my university, we're also just starting about 3 or 4 years ago, teaching specific sustainability courses. But a lot of the departments have renamed themselves Geography and Sustainability, or I saw one, Geography and Environmental Sustainability. And at our other university, University of South Dakota, it used to be the Department of Earth Sciences. They've renamed themselves Department of Sustainability. A lot of them are moving away from topics in geology and into topics in sustainability. The very last thing I want to say is funding, where we get our funding. We have what's called the National Science Foundation. So that's our most prestigious granting agency, we say, from our government that supports science, all sciences. And so this is theoretical sciences, advanced sciences, the agency's there to support research and the discovery of new information. We have other national agencies that also support science, but they also have missions to manage and oversee things that are important to us, like the National Oceanic and Atmospheric Administration deals with weather issues and very practical problems affecting people, but they also give funding to science as a means of solving some of these practical problems. We also have NASA, National Aeronautics and Space Administration. I think you know about. People know them for like the space shuttles and our space exploration, but they're also concerned about Earth space. Because we're an agricultural university, we get funding, for example, from the Department of Agriculture to do much of our work. And then lastly, I want to point out is something that's not national, but more local. I mentioned that I have a colleague who is doing fire evacuation in California. So he actually went to one city, a small city up in the mountains in California. It's a resort city. It's maybe someone similar to your, I think it's Bukovel, which is, a ski resort city. But in the summer, tourists go there as well because there's a big lake, a famous lake called Lake Tahoe. And but it's an area with a lot of fire. So he went to the city and they gave him something like $50,000 to do research on creating a fire evacuation plan for his for their citizens if there's ever a fire there. So that's it. I hope that was informative. It wasn't too boring for you, but I'm happy to tell you some of the things that are going on here in America, the way geography is going.
Thank you, George. Andrei Severikov has a question.
Yes.
Hi, George. What a pleasure listening for what you're doing. And within your presentation, there was a topic regarding the application of GIS and remote sensing within the agriculture. And you mentioned the precision agriculture practices, which are becoming popular in the United States. So before we get to the topic of the mineral critical resources exploration, oil and gas exploration, and geology, we used to build artificial intelligence for digitalizing agriculture, and especially the sustainable agriculture. So while doing that, we get in touch with a professor from Chico University in California. His name is David C. Johnson. And do you know this guy?
No, I do not. I know Chico.
Actually, they have an experiment in North Dakota. It's quite close to the place where you are now. And they have very, very little agricultural season. And like they have like 60 days, sunny days a year or something like that. So that makes them to be really efficient to keep their agricultural business above the zero level, including some risks. They have ice hails and other stuff. So they apply this sustainable agriculture technique, taking into account smart, climate smart agriculture management practices. I believe I can get you in touch with him because he can bring a lot of use about the information about field and agriculture as an ecosystem. While cooperating with them, we build an kind of digital copy of the agriculture, including the microprocesses within the soil, microbiotics, fungus, and bacteria, how they convert the minerals into the forms that the plants can consume and be more efficient in the way they grow. So basically, that can be a handy thing. And the other thing I want to ask you, is there is a way to gain access to the data of the data facility you're connected to, as I believe there is a lot of open data available through the USGS Earth Observer or Earth Explorer portal, but there is still something which is quite hard to get, like the data from the Hyperion satellite or some data on the radar-based satellite, like RadarSat-1, RadarSat-2, and most probably some shots from the Sentinel-1, I think, also there.
Okay, okay. So you're wondering how you could get access to it?
Yeah, indeed.
Yeah, I can ask some questions to some colleagues, and I could see what I could do for you. You could either send me your information or send it through Dmytro. Could give you my contact information.
We can get in touch here.
Yeah. Actually, I will put in the chat my email address.
Well,
Yeah.
here you can see a mail of George. Thank you very much, George. Your presentation was very useful. Is very useful
Okay, thank you.
For us in Ukraine to know all the different interesting research in GIS and geography in the United States. Thank you. And now our agenda is another presentation from Zoriana Hostiuk National Nature Park Hutsulshchyna, the use of the smart system in the activities of the Hutsulshchyna National Nature Park. Zoriana called me. She has no electricity, and because of Russian aggression and Russian missiles. So nowadays I will share the screen, and you can see her presentation in recorded. Inform me about availability of the sound, and I will stop and translate every slide.
Всім доброго дня. Хочу представити доповідь за темою використання смарт-системи діяльності НПП Гуцульщина.
Once more. Так.
Що ж таке ГІС? ГІС – це система, яка забезпечує збирання, зберігання, опрацювання, аналіз, відображення та поширення просторових даних, а також оформлення і друк необхідних текстово-графічних звітів.
Here you can see what GIS is.
В діяльності НПП Гуцульщина використовується декілька GIS-систем чи технологій. Зокрема, це є ArcGIS, QuantumGIS та SMART. Більш
In the Hutsulshchyna National Nature Park, we use several GIS products, ArcGIS, QGIS, and SMART system.
детальніше ми сьогодні зупинимося на смарт-системі. В 2021 році в рамках співпраці Франкфуртського зоологічного товариства з Національним парком впроваджено в роботу нове програмне забезпечення SMART. В основному SMART використовується для напрямку розвиток моніторингу біорізноманіття в природоохоронних територіях Карпатського регіону. Крім науково-дослідного відділу, звичайно, вона використовується службою державної охорони та відділом рекреації та благоустрою територій, походів.
The smart system has been developed with Frankfurt's Zoological Association and National Park. This software used for monitoring of biodiversity in natural protected areas of Karpatsky region. For example, guards and scientific staff, recreation department, and so on.
В 2021 році в рамках співпраці Франкфуртського зоологічного товариства територій існують дві версії SMART. Перша – це мобільна версія, яка призначена для збору інформації в польових умовах, та комп'ютерна версія, в якій вже безпосередньо обробляються зібрані матеріали під час польових походів.
There are two versions of smart system exists on the mobile platform and on PC.
Походів. Є два способи збору інформації в польових умовах. Перший – це є фіксація даних у вигляді патрулів, де записується маршрут і безпосередньо спостереження на цьому маршруті, і фіксація у вигляді окремих інцидентів. Після збору інформації в польових умовах необхідно цю всю інформацію передати до комп'ютерної версії, де буде безпосередньо і проходити обробка цих матеріалів. В комп'ютерній версії матеріали зберігаються у вигляді двох видів. Це є у вигляді патрулів та у вигляді інцидентів. Звичайно, цю інформацію можна переглянути.
Well, the data captured are storing in few different formats as a points and as a raw tracks of patrolling the territory by security staff. The software can store data as points, as tracks, and in map view, where also photo images can be added to the GIS project. The software allows to make spatial queries to point of interest, and we can obtain the information about statistics and all necessary information about the area. This is a result of the query. The result we can see the number of patrols, the distance that they have done, how long was this patrols, some incidents of the area of the National Nature Park, and also cartographical representation is available. Except general indicators of the observations, you can create particular information as tables and maps of red list plants, mushrooms, and other biota. Here you can see the result of the work with smart software. 22 staff persons have been working with 19 mobile devices, and they have been captured a lot of observations and fixed geographical points of different plants, and so the use of the software is very important in the work of the National Nature Park. The GIS software is very important in the work of natural protected areas. Thank you for your attention. Well, Zoriana unfortunately cannot join us because of poor network connection. So we have, if someone has questions to Zoriana, you can type down the questions in the chat. Well, we have one small, maybe last presentation. It's a presentation of by Ivanna Zobniv. Давайте я тоді зроблю цю презентацію, тому що, якщо Івана присутня, можете прокоментувати вашу презентацію чи ні?
Так, я можу під'єднатися.
Будь ласка, приєднуйтесь. Тоді я буду демонструвати, а ви говоріть.
Окей. Мене чути?
Да, вас чути прекрасно, будь ласка.
I want to talk in experience this practice with the University of Urbino. It's Carlo Bo from Italy. This practice from GIS technologies in earthquake monitoring. Наступний слайд. Purpose of the work in this study, we applied digital image methods to investigate the area where a historical seismic event occurred from June 1781. A strong earthquake, 6.5 MW affects the northern sectors of Umbria, Marche, Apennines. About the disasters caused by this event was reported in many agricultural documents of the time. This work is a made for finding a correlation between the Monte Nerone fault and the earthquake in the Marche Apennines in 1781. The fault crosses the Monte Nerone ridge. Its region Pew, short name, continue to the west, to the north of several di Corca, and extends in sources direction to mountain La Montagnola. Montagnola, it's Italy name solved in the work of the problem. We have two problem, and one this mapping of the main fault on the Monte Nerone anticline, and two this search identification and characterizing of possible faults. Norway fault system in the area of Monte Nerone. Наступний. Is this location of the districts, and this location its region marker is location in the center of the country on the coast of the Adriatic Sea. You want the sea left point, and you have image of the research area on the servers Google Maps. It's Paris Marche, the capital of the province of Pesaro. And Monte Nerone is a mountain in the Marche region, belonging to the Apennines range of Umbria Marche, location in the municipality of Pobicchio, Apecchio. This is province of Pesaro and Urbino, the heights of which research 15-25 meters above sea level, with height difference of 120 meters from the bottom of the whale. Its location of the north of the Monte Carchia or groups with two Gotthard divides the mountain in its name Carchia to Nerone. Next. This you see image to three mountains belong to the Apennines. It's Umbria Marche, this right of the territory research. It's we start the Monte Capegna, and central location is this Monte Nerone. We have with this many research, and finish we have Monte Catria. Next. This is schematic tectonic maps of the north sectors of the Umbria Marche. This north Apennines on which a black box, it shows the study area and traces of faults. Next. The territory of the study is internal sectors or sectors of Umbria, Marquesas, Apennines. This provides the Pesaro Urbino to northern part of the Marche, which includes the Monte West edge of Monte Nerone, anticlines and the adjacent area of the vale of the rivers, rivers Biskubio, and one Biskubio and another tributary. The stratigraph can be summarized and as a carbon sequoia of Virsky to Virsky to Oligones H. This succession was deposits in a basin of the margin of the African platform during the transition from sand rifting and drift and development of the margin. This is simplifies geological map of the studies area from the geological map of the Marche region of scales scales 1.20 millions. This array line include the traces of faults mapped in this region. Next.
Івана, давайте не так довго, а більш компактніше, пришвидшимо. Раз?
This stratigraphic column, it's Italian abbreviature, and we have its Miocene, Paleogene, and Cretaceous period. It's detail you want write, and next. And it's продовження. This it's work processes methodology. Work on soundings of Monte Nerone main fault was development in several stages. One project prepared two project, its location survey, and three this data processing and sciences. It's laboratory and field work alternate from beginning to end. At the beginning, preparation work was carried out in the laboratory. You want methodological workflow with places of surveys and mapping process. This one. This project preparation, it's first produced. A project was developed at the university using QGIS 3.24 surveys, which configure the work filed according to the needs of the detection field assistant. The project includes SFTM of Marche region and geological references map basis on the International Ellipsoid Center on the Monte Mario. It's Rome. It's a cartography, a geological map at scale and satellites, orthographic networks of references areas. It's three maps. After that references layers were created in the form of the shape file to be able cartograph and share the information obtainable in the file of the following. It's deposits layers dedicated to measurements and registration of earthquake layers, exposed selected layers for fault coating layering. Different fields are created for each layer, where you can begin to type of information, data, measurement by setting three main fields. Next, it's metadata. It contains such information as the identificator, detector, performing, the measurement location, and the data. Next, it's data. It's containing measurements data and annotation, where you can insert notes for comments of attachment, such as photo or log files. It's you see on the left, it's illustration of the mine layer with the corresponding types and symbols. On the right, it's example of data collection for deposits. It's a topographic surveys on the data area. You see collection took place in May. In it's 2022 years in May. Noise of the in use as traditional, so digital, and their tools. The traditional tools use to buy geologic. You see photo and interesting. It's program surface you have in a laptop, and Gamping Glow. It's Bluetooth GPS. Then the data collected using the measurement were entered into the project file describes in the previous section using table PS, which will facilitate the catalogization, thinking and sharing of the collected information with the help of a Bluetooth GPS connected to a table PC. Was possible to have an accurate tributary of the position where the measurement where takes making and traditional paper to do. You see this photo digital instrument and requirement are why Quantum GIS? Because it's a multi-platform open source in Linux, VS, MC Windows, Mac OS, GIS Surface, and this collaborate stable, minute and good documents, very well comfortable and for free. It's the OCG of 4V. Its repository contains many surveys from OS Geo project, QGIS, and all the dependencies includes as well as Python, graphs, GLAB, DAL, and etc. This is the best surface source for people who want to able to airs updated dependent from repository. It's a system coordinator Francis system SRC control when you import bitmap of vector maps of SRC selector Windows will append. For SRC we choose APCG Monte Mario Italy zone, and also you can create PGR.
Your all projection,
parameters.
yeah.
Yeah.
Let's move on. Yeah. And this is
it's can no, QGIS can manage of strings of a main data from GPS RSX is we integral GPS and its program when we go in location. It's data processing. This the data and the measurement were collected using traditional tools, then analysis and catalogs digitals northern positions, orientation and the types directory in the QGIS project, added information separately having digital forms of works. It was possible to comment and shape with other students information and assisting countings of sites, and the measurement presented its data and information. It's this we have illustration of the road observation and stops where data were collected. It's yes, it's a example point observation. It's stop point 8. We measurement were also carried out the sources school and its school of Pietralunga, where different types of formation were found, such as a monitored alternative marls and limestones with characterizing red color. Its fossils formation reaches ammonites and surface faults is gray, homogeneous regulation layers, microclimating salt marks forming formation with may containers strong spoiler course, radio layer from foraminifera, and another amount is the here the presence of general violations with a deep of 20,000 grados was revealed. The fault divides the carniolites formation with separate vertical layers with a deep of 15.4 with angle of inclination of 19th and near the layers with a deep and with angle of inclination. Into this we have it's the north eastern sides growth with with Petrolunga. It's image of the observation area. And next. It's northern west side of the Cornelia suite. We have location and all we have do the out and its location. It's a short video is project. No, внизу там скрол є. Якщо відкрити. Ні, саму презентацію. Якщо згорнути.
Не працює. Ага.
It's point photo and this orthophotographic plan. Its location where we measurement. It's geological maps.
To the result, please.
Yes, the result thanks to observation and measurement of the faults and naval out course along 2 rows, it was possible to record the continual of the mountain Nerone faults in the north eastern direction with a length of about 9.9 kilometers. In editing having a SRT with a geological map, we were able confirm of any certain geological deposits is and this all conclusions we have begun work to dispose of confirm correlation basis of the Monte Nerone. Nerone fault with the mark in 1781 Apenninic earthquakes. The faults crosses the Monte Nerone ridge. Continuous westwards north of Seraval of Carda and extend the sourcewards or to Monte Nerone La Montagnola. It is natural that his territory was involved in normal kilometer kinematics and seismogenetics evolution causes by related families of fowls. Since of research activities and observation is the studies area. With the help of the measurement, it was possible to sites that the Monte Nerone fault extends from the west, starting from La Valley, crosses the western, southern and eastern skulls, Monte Nerone, and extend the Monte La Montagnola, continuing the Pietralunga on the wall along its length of approximately 9 of 10 kilometers, taking into account in immersion of 54, its inclination is 19 rocks that we measurement along the entire route. We can assume that there was an earthquake superfiction with its maximum depth of about 10 kilometers.
Well, thank you. It was very interesting presentation. And now,
thank you.
We just it is the end of our agenda. Finally, I want to present. Our time is over. I just now I must work with my students. So finally, I want to present 4 winners of our well, I will show you a screen. I must give prices. We have 5 ArcGIS licenses. We have got them from ESRI. And this individual ArcGIS for personal use licenses to be distributed at our GIS Day event. So it's subscriptions for ArcGIS for personal use and story maps subscriptions. We decide to give these licenses to best students. Someone up here, it's Ivanna Zobniv. She has got 1 license, and then it is Bogdan Tikhanenko. He is absent. And another 2 students from land evaluation department is Alina Abdullaeva, 2nd course, and Solomia Mokanu. So best wishes to students. They can contact me and get these licenses for personal use during 1 year. Thank you for attention. Thank you very much for everybody. Andrei, sorry, I have no time. My students just joined this conference instead of our lecture because we have lost our time. Well, I think that we should continue our communication and our collaboration. Thank you for attendance, for joining us. Goodbye.
Yeah, thanks, Anton. Bye.
Bye.
Goodbye. Well, recording is stopping.